Are we good to go now? All right. There we go again. All right. Yeah, no, really no worries, Tim. It's totally fine. Thanks for organizing this event. I know it's always a lot of work. Um, yeah, so what are we doing at Centrifuge? So what we're trying to do is we're kind of trying to create a bridge to bring real world assets into DeFi, into decentralized finance. And what that means is kind of right now, crypto and DeFi, it's really its own world. DeFi projects are interacting with each other, but it's really all kind of interconnected, but not really connected to the broader real world financial system. And what we're trying to do is we're creating the technology infrastructure to actually be able to bring assets from the real world into DeFi and into the crypto space. And the way we do that is we have a product called TinLake that enables someone, a lending business, to tokenize their real world assets and then bundle them in a pool, in a kind of a liquidity pool, and then create liquidity LP tokens from this pool and move those LP tokens around in the DeFi ecosystem and find liquidity for them. That is a lot of different words and a lot of different keywords. So in the rest of my presentation, I'll go into the different bits that are involved there. But basically, on a very high level, that's it. We're creating the technology infrastructure to broaden the space of DeFi and include real world assets in it, which is an incredibly huge market that we're kind of able to tap into and we're able to grow the space too. Yes. So I wanted to start because this was a very high level interview. I wanted to start with kind of at the small beginning at the NFT level. So let's say you have a house. This is a nice house, I think somewhere in Florida. And let's say you want to take a loan against this house as collateral. Now, what we do is actually we kind of take some public information about this house, like what is the value of this house, and also some private data about this house or about the borrower of the loan, like what is the credit score of who's trying to borrow, what is the address of the house, and so on. Like different sets of like public metadata that describes the asset and private metadata that describes maybe the asset, but also the borrower or the involved parties. And we bundle this information together into an NFT or a non-fungible token. This is what would be called tokenization. So it's basically creating an on-chain representation of some off-chain collateral. That's kind of the first step. So for every collateral that you want to kind of use on-chain, you'd create an NFT for it and do that. What we then also do is we or any of our pools create a legal entity in the real world, and what's called an SPV, that would kind of hold the legal rights to this off-chain collateral, and that's kind of where the off-chain part ends. And what we then want to do is actually we want to create a liquid marketplace for these real world asset NFTs. And the way we do that is we have created an protocol. It's about 20 different Solidity smart contracts that are live right now on Ethereum mainnet, where a borrower can then lock this NFT into the pool, and they can bundle these different assets, these different NFTs together. So they on the one side, the issuer or the borrower deposits NFT and bundles them in a pool, and you get a bunch of different NFTs that are similar asset class or so together. And then what you can do using that pool is you can create different tranches. So this is a financial concept from the traditional finance space that's normally called securitization. So what you're doing here is really you're creating different risk classes for this pool of assets. So we call this drop and tin or the senior tranche and the junior tranche. You might be familiar with this maybe if you've used Barnbridge as well, or some other protocols that are doing similar things. Really what you're able to do here is you're creating LP tokens, so tokens that people can invest kind of part or like they can buy a share of this pool, but they're able to buy either a drop token or a tin token, and this depends on kind of the risk class that they're interested in investing in. So the drop token is kind of a more stable yield, but a lower risk level. And the TIN token is basically a higher yield but higher risk level as well. So really what's interesting here is that these TIN tokens are often very interesting for kind of individual investors or DeFi native investors that are really interested in a specific pool and want basically higher yield, but also want are able to kind of spend more time analyzing and figuring out how risky a certain asset is. And then drop tokens are very interesting for maybe larger institutional investors, or and that's where it gets really interesting for other DeFi protocols. So right now you have a bunch of different DeFi protocols, like for example MakerDAO, that has a large collateral base in different crypto collateral types. So MakerDAO is a large share of crypto of collateral in USDC, in ETH, and in other in different crypto tokens. But all of these crypto like collaterals are very highly correlated. What that means if there's potentially a crash or if there's volatile crypto market, then this will have a huge impact on kind of the stability of in this case DAI, but depends on the protocol. And so what they really want is they want stable collateral backing their token, and that's where kind of real world assets come in. So these drop tokens that I mentioned, which are the more stable, safe tokens in these pools, can be used for Maker as collateral, and that's what we've been working on for quite a while. And I'll get back to like in more details about it in a second. Before I get into that, I wanted to give a few examples of our product. So our product is already live. This has been running on Ethereum for about 1.5 years. Right now, we have about 45 million in TVL. And what it actually means is we have 45 million in loans that's been given to real world assets and actually been used for very clear use cases. So a few of our examples of our pools right now are Neil Silver. This is our biggest pool. So they are a US-based real estate provider. So they provide bridge loans for the real estate market in the US. They use technology to actually hand out these loans, and they use kind of our infrastructure and our protocol to get financing for these loans from the DeFi sector. And yeah, that's really exciting. The other another example is Fortunify. So they're an issuer that's focused on what's called revenue-based financing. So this is financing to companies, or mostly tech-enabled companies, who want to kind of get advances on their future revenue. And they are working together also with Pipe, which is a big player in the space, and they're growing very quickly. And lastly, the example I want to mention was Branch, which is a kind of emerging market micro lending fintech. So they're providing. There's a pool also live on our product that's providing, I think, about 5 or 6 million in loans right now to Branch to actually hand out in micro lending to individuals. I think mostly in India. So that's 3 very diverse, very different use cases that are all actually live right now on Ethereum and actually being used. And you can actually go to our app, TinLake, and actually invest in these different pools. So yeah, here just a screenshot of the entire list of pools that we have live right now. So I mentioned a few already. There's also others like the Gig pool, which is providing kind of gig economy payment advances, which is really exciting and growing quickly. And Conservate, which is kind of cargo and invoice advancing. Yeah, many more. So getting back to what I was mentioning before, so these drop tokens are particularly interesting as collateral for other DeFi protocols. And we've been working on for quite a while on an integration with Maker. So we have 5 different vaults that are onboarded with the MakerDAO protocol right now, and 4 of them or 3 of them are actively using this integration. So basically, they're able to deposit their drop tokens into a Maker vault, and they're able to draw DAI as a loan against this real world asset collateral. And I think it's quite cool to mention that like, this is really a new paradigm in the way that we're really like using this off-chain real world collateral, creating on-chain tokens that represent shares of these different assets, and then drawing DAI, which is an entirely on-chain stablecoin, against these assets. And then again, that DAI is then converted to USDC and then drawn down to fiat. So it's really the whole chain that's happening here. We were the first partners to work with Maker on bringing real-world assets into the protocol. The other protocol that we're working with right now is we're working on launching a market on AFA as well. So this is something that if anyone has been following Centrifuge, you might have heard us about. It's in the very final stages right now of actually launching this. So basically what's going to happen is there's going to be a new market on the AFA protocol where people can invest USDC, and they'll be investing in a bunch of these different drop tokens, kind of an index fund of different drop tokens. So yeah, it's kind of offering a really exciting alternative to just investing USDC in a crypto only market, and actually getting exposure to these real-world assets, which are very stable and quite interesting diversification option. So yeah, here's a little bit of a sneak peek. This is what we're working on right now, and it's going to be live very, very soon. Yeah, so that's what we've been doing. We have Tinlink live on Ethereum. We've integrated with Maker. We're very close to integrating with AFA. Besides all of that, we also have our own blockchain called Centrifuge Chain. This has been built on Substrate, which is the technology behind Polkadot. And we've been working on actually moving over more functionality to this chain. So we already managed to become a parachain on Kusama that's called Altair, and we're going to launch some functionality, some very exciting functionality on there soon. And the next step is actually to move this product that I talked about, that's called Tinlink, to our own chain as well. And this is really cool because like Tinlink on Ethereum, it's quite limited in its users. It's very expensive to use, like all Ethereum protocols, and it's quite limited in what we can do with it. And when we move Tinlink to our own chain, well, it will become a lot cheaper, which is makes a lot of more things possible. It will also make it a lot easier for people to launch their own pool. Right now, it's quite complex and requires a lot of work. But we actually have the vision that anyone would be able to easily create their own pool and easily bring their own real-world assets into the DeFi ecosystem. And I think moving over to Centchain will be kind of the first step to achieve that. And it will also be possible to kind of customize things a lot more. We can really do whatever we want to do and whatever we can think of, honestly, on Substrate, and it's quite exciting. And the goal here really is that we become kind of a highly optimized blockchain specifically for real-world asset financing, and making that possible. And then our own chain will be kind of the hub for doing a lot of this activity, for like tokenizing assets, bundling them, and so on. And then we'll actually take these LP tokens, what are called drop and tin right now, and actually move them into this kind of multi-chain universe that we're now talking about a lot this year, and actually bridge them to kind of other parachains in the Polkadot ecosystem, or bridge into Ethereum, or even bridge into other chains like Celo or whatever. On any chain that is interested in real asset collateral, we envision that we're able to kind of take the LP tokens from our chain and move them around and really create a liquid marketplace for real assets. That is it. That's what I wanted to talk about. I think there are a few questions in the Q&A.
Yes, there are a couple of questions, and I'll read them to you. But first of all, thank you for that great presentation. What are the chances of Centrifuge winning the next parachain auction? What's that looking like?
Yeah, we're really excited to get going, and I think it's a few more weeks for actually to start. We have. I was really happy to see with Altair we had. I think in the second batch at least we had the most number of like small contributors, which was really exciting to see, like a huge community support. So I hope that we're able to get that community behind us again for the next Polkadot cartels.
Nice. Yeah, definitely very, very exciting things to look forward to for Centrifuge and real world assets too. And we do have some questions from the audience, so I would like to read them out to you, and perhaps you could share some insights about some of these questions. So question number 1 from Anonymous with 2 upvotes. How does Centrifuge handle privacy if real-world assets with sensitive information, such as addresses and personal identifying information, are collateralized on chain?
Yeah, that is a really good question, and exactly like one of the big problems that needs to be solved. I think I hinted at it a little bit in the beginning, where I was talking about we have an NFT that has kind of public metadata and private metadata. And this is like, I didn't dive into it because of time, but this is where kind of the solution starts. So what we do is we have some kind of public metadata that we put on chain. Like this could be the value, this could be the maturity date of the loan, this could be the debt, the current debt, and so on. But obviously, like the credit score of the borrower, that very clearly can't be public information, and there's a lot more information that that we can't put on chain. And what we actually do is we have our own peer-to-peer protocol that kind of runs separately from the blockchain that enables anyone to kind of create private documents and share them with interested parties. What this means is that kind of any of our issuers that create their own pool will put in documents that represent these assets and share this private information with investors and other parties that are involved in the pool. And then what we do is when we create these NFTs, it doesn't contain this private metadata, but it does contain kind of a verifiable link to this private metadata. So we can kind of show and we can verify that the public NFT is actually linked to this private metadata that is being shared off chain with the parties that are able to see it, but isn't actually being made public. So I think that's the way we're kind of approaching that problem.
It's nice to know that you guys are definitely thinking about that. So thank you for that answer. Next question, also from Anonymous with 2 upvotes. That's pointless to say that, honestly. But if you collateralize a house, say, does a title change owners, or how do you prevent something like a double spend, whereby an owner sells a house that is simultaneously being collateralized? Good.
Yeah, that is also a really good question, and these are definitely the big problems that need to be solved in this space. Basically, what we do right now is we like an individual couldn't really use our protocol. The way it works is that there's always an issuer of the pool that's running the pool and that's managing it. And these are generally kind of lending businesses in the real world that specialize in a certain asset class. So for real estate, it would be Neil Silver that really does this. Like they focus on kind of providing loans against real estate. And so what they do and what their role is they when someone wants to take a loan, they approach them and they underwrite the borrower, they underwrite the asset and so on. And then when they buy the collateral, in this case house, they will how do I say, it's like move the property rights into the legal entity. So there's always an SPV, a single purpose vehicle. I think in New Silver it would be like a US-based Delaware LLC that would own the property, and that would actually, yeah. And so when you're actually investing in a pool, you're also going through KYC and you're also signing a subscription agreement, which also gives you certain rights as an investor into this pool. And that basically gives you the right to cash flows coming from this collateral in this off-chain SPV. So that's kind of the technical answer. I would say the broader answer is really, in this case, we're also not really reinventing the wheel here. There is a very common off-chain legal infrastructure to provide financing for real estate, for example, and that is all there. Like we're not completely removing that. We have all this off-chain legal infrastructure, and there is a lot of legal agreements, but that's kind of happening separately. If you just do that, you wouldn't have any transparency on chain. And we add kind of the Tin Lake protocol to actually make that public on chain, create a liquid marketplace out of it. But the legal infrastructure is still there. And yeah, maybe the other thing just one thing to add is that you also asked about like double spend. There is still some trust here in the issuer. Some of it is removed because they need to have some skin in the game. They need to hold some of the tin, so that junior tranche. But in the future, we also want to improve this even further by adding kind of an underwriter role to the system. So there will be kind of a third party that actually is separate from the issuer and will be verifying, in this case, that the house actually is possible to be used as collateral, and is it already used somewhere else.
Thank you for that answer. And then we have one more question from Mike Ankelev. What does a process for recovering funds look like in the event that a loan defaults?
Yeah, it's tying back to the same question, same answer about not reinventing the wheel entirely and using some of the things that work well. Like for real estate, for example, there's a very common, like I'm not a lawyer, so I can't answer the exact details here, but there it is a fairly standardized way of handling defaults. and the issuer, in this case Newsilver, would be going through that standardized process. And the way that as like an investor you have rights is that because you're signing this agreement with the issuer, as you actually get rights to the cash flows coming from this. So in the case of a default, the issuer would be the one handling this and would be the one trying to recover the funds, and would be the one any funds that would be recovered would need to be repaid in the Dynamically protocol that is kind of legally protected. Yeah.
And finally, are there any competitors doing similar real-world asset financing solutions?
Yeah, I mean, you definitely see that it's like starting to become more hyped, and there's definitely starting to become more players trying to work on this. I would say there's a lot of quite a few different ones that are kind of tokenizing real estate, for example, where they're kind of tokenizing an individual asset. So you might be able to buy like a token that represents a single house somewhere. We feel that kind of using the securitization approach makes it possible to create much more of a liquid marketplace for these assets. Rather than like investing in a single house, you need to, it's much more illiquid, and that's really what we want to avoid. And there's also some other RDBA players that are more focused on kind of under collateralized lending, based on a reputation. So kind of individual loans where they're kind of trying to build like a credit profile on chain and so on, and then lend against that. But that's again quite different. Like what we were focused on is really the securitized lending for kind of highly, like it's fully collateralized, just collateralized by real world assets instead of crypto. And I think so far there's no other companies doing exactly that.
It's definitely a really cool thing that you guys are doing with the whole collateralization real world assets. So exciting things to come out of Centrifuge. Looking forward to what comes next for 2022 for your team. But thank you for your time. Thank you for participating in CSCON and giving a presentation. Really appreciate it. Thank you so much.
Yeah, thank you so much for having me, and have a great day, everyone.
Feel free to stick around and listen to some other talks. We got Light Clients coming up, and then Joe Lubin later, and Robert Habermeyer from Polkadot in about half an hour. So
nice, cool. I will.
Cool. See you around. Thank you. Okay, bye. Okay, all right. That was a great talk from Jerome. Thank you so much to the Centrifuge team for participating in CSCON 1. Now, up next, we have Light Clients. Light Clients, otherwise known as Matt Garnett, IRL, is a member of Quilt, a group focused on applied research relating to the Ethereum protocol. He is actively involved in the Ethereum governance and specification bodies. He is particularly well known as a champion of EIP 3074, which proposes adding auth and auth call opcodes to Ethereum. This is Light Client's second time joining us for a ChainSafe event, the first being the Ethereum Developers Meetup for Toronto a couple of months back. So thank you, Matt, for always supporting ChainSafe events and for participating in CSCON 1. Today, he'll be talking to us about Ethereum accounts of the future. So Matt, feel free to unhide your camera, unmute your microphone.
Hi, Tim.
What's up?
Thanks for having me. It's fun coming to the ChainSafe events.
Love it. Love when you participate in any of our events. So I'll let you take it away.
Sweet. Let me share my screen. So this is kind of an extension of a talk that I gave earlier at the ChainSafe's Ethereum Toronto meetup. And it's kind of funny because a lot of talks that I seem to give for ChainSafe events, I then take to like larger conferences. So I gave the 3074 talk at the ChainSafe event earlier in May. And then my coworker and I presented basically the same talk again at ECC. So if you guys are coming to ChainSafe events, you guys are really getting this like really good alpha. I would guess that this is a kind of a presentation I'll give at another conference here, maybe next year or something. But if you haven't seen this 3074 talk that we gave at ECC or the one that we gave to ChainSafe, I recommend checking that out. This is kind of an extension of it. And I will talk a little bit about some of the points that I talked about in that talk, but this is really going to talk about more about what the future could look like in many different ways, rather than just focusing on this one EAP, this EAP 3074 that Tim mentioned. So with that said, like Tim said, my name is Matt. I go by the like client on the internet. This is my avatar, if neither of those names ring a bell. And today I want to talk about what I think the future of accounts in Ethereum could look like. So before we talk about what the future of accounts at Ethereum could look like, we should look at what accounts today look like. And so there's really these two types of accounts. There's the externally owned account, which we tend to abbreviate as EOA, and then there are smart contract accounts. And when you think about an account or like a wallet that you have, you generally are thinking about this term EOA, externally owned account. This is what your Rainbow wallet is, or MetaMask. It's controlled by a private key, and it has the special property that it can originate transactions. And by originate transactions, I mean that it could kick off the process of a transaction executing. This is something that a smart contract can't do today. So you could deploy some sort of smart contract wallet, and you would still need to have an externally owned account that originates transactions that go through your smart contract wallet. The caveat of this is that EOAs cannot today execute code, while the smart contract accounts can execute code. And so we have this sort of conundrum where we have these two nice things of functionality, originating transactions, executing code, and we have two types of accounts that are doing one but not the other. So that was like a recap of the accounts that we have today. Why are we even talking about what accounts could look like in the future? What's wrong with accounts today? If you're wondering what's wrong with accounts today, you must not be using Ethereum very much, because it's incredibly painful to use Ethereum. And there's quite a few problems that we have. So for one, and probably the most painful thing, is you generally need a separate transaction for token approvals. This is, to me, one of the most frustrating things about using Ethereum, and one of the reasons that I use Ethereum so infrequently is because I don't like having to start using a new dApp and approve 3 or 4 transactions. I think that as we start, expanding with more complicated applications, having this tendency to correlate actions one-to-one with transactions is not going to allow us to scale the complexity of some of these systems. Then there's this other really bad problem that if you lose your private key, you're pretty much done. There's no defense against this today. If you're using just an externally owned account, you can write down your mnemonic somewhere, but we know human nature. We write it on a piece of paper, pen it to a refrigerator, put it in an envelope somewhere, and it somehow gets lost. Or there are catastrophic events like natural disasters that can really make you just fully lose everything in your home. And so this is a problem that's keeping us from really reaching mainstream adoption with people. It's also not possible to perform actions without Ether, because EOAs are originating transactions and they have to use Ether to pay for those transactions. So as these platforms continue to grow and expand, and we bring more people into the fold, and we start paying them with different currencies other than just Ether, now they have to go acquire Ether before they can move any of their assets. This is really not ideal. And all of these problems tend to come from this root problem that contracts are authenticating everything with this message.sender concept. So in Solidity, there's this thing called message.sender. And if we look at the transfer function for an ERC20, we can see, if we zoom in on the second line here, that the message.sender it's not a parameter to this transfer function. The two parameters are 2 and value. Message.sender is actually like a context variable that exists within the EVM. And the sender of the message is actually the account that is having the value deducted from it. And the reason I say that this is like an authentication mechanism is that this function is assuming that because this function was called by a certain user, that user passed the 2 and value fields and made the call, and therefore they are okay with whatever the outcome of this function is. And so that's basically like the kind of implicit authorization that we are relying on when we have assets controlled by the message.sender. And just to like hammer this home, if you think about like a more complicated call graph where you have some user EOA originating a transaction to contract A, this is the only time in the call flow where you have message.sender equal to that EOA's address. Other than that, as you start chaining calls, contract A becomes the message.sender, contract B becomes the message.sender, and this makes it impossible to chain commands, chain actions together that rely on this message.sender, because this is the only time where the EOA's address is equal to that. So, to move beyond that, to solve this, we have like a few solutions. And for a while, people have thought like smart contract wallets is the way to fix this. And if you like look back at what people thought in 2015, 2016, maybe 2017, we thought every Ethereum user is going to have a smart contract wallet, and this is going to be the best way of interacting with the chain. And maybe it was back then when fees were, when it cost 10, 20 cents to deploy a smart contract wallet, but now it costs $20 to $200 to deploy some sort of proxy contract. And even if you do have a smart contract wallet, it's not a very seamless user experience interacting with dApps. So I don't think that this is really a solution that's going to reach the mainstream unless we do something at the protocol to improve what we have. So this kind of gets back to the original point, is like, okay, what can we do in the future to improve accounts and make it better, fix these UX problems? And so these were the two types of accounts. They both sort of have some functionality that the other doesn't. So what if I just told you that it was possible to both originate transactions and execute code, rather than having these two types of accounts that just do one or the other? And that sort of leaves us with these two scenarios where we can either allow contracts to originate transactions because they can't today, or we can let EOAs execute code because they can't today. If we look at this first one, let contracts originate transactions, this is an idea that's existed for quite a while, and we tend to refer to this as account abstraction. This is probably a term that you've heard thrown around here and there, but it's been around for quite a long time. This is kind of the original abstraction EIP that Vitalik proposed in 2016. And it was the first sort of proposal of, hey, let's have some sort of way of allowing contracts to originate transactions. And I realized as I was making this slide that he posted this on April 1st. And now I'm starting to think, like, was this just a joke this whole time? Like, we've spent quite a while working on account abstraction. Was this really an April Fool's that's gone too far? I don't know. I think that account abstraction is definitely a good proposal. In fact, the Quilt team worked with Vitalik to write this EIP 2938. And I'll just give you a quick summary of how account abstraction works if you're not really familiar with this flavor, this protocol flavor, 2938. So if you take a transaction, you could allow account abstraction to occur by instantiating the call into the target of the transaction. And by target, I mean, if you look at the transaction to field, this is the target that the transaction is going. So you would fill that target field with whatever your smart contract wallet is. And so then whenever the EVM is executing in that frame, your smart contract wallet, the caller would just be set to some constant address, like all zeros or all Fs or something like that. Then you would allow that transaction to execute up to a client configurable amount of gas. And if the transaction in that amount of gas does not call this opcode pay gas that's introduced in 2938, then you consider the transaction invalid. If it does call pay gas, then the transaction is considered authenticated and it may continue executing up to the gas limit. Because when you call pay gas, you're basically saying, I have performed the validation logic necessary. This is a transaction that has been authorized by the owner of this contract, and therefore I'm willing to pay this gas price times this gas limit to continue executing it. And we can frame the way that EOAs work today in the same manner. You can imagine that this 21,000 gas that you pay as like an intrinsic cost for all transactions could be this in value. And in that in value, you could imagine that every EOA is a really short smart contract that basically takes the signature of the transaction and recovers the address that's sending it. And then it looks into the state to determine, is the nonce of this transaction correct? And is the balance of this transaction correct? And if so, then call this pay gas opcode and allow it to continue executing up to the gas limit that it's specified. So this is kind of the nice way of thinking about account abstraction using sort of the way that we understand EOAs to work today. there's also something that I won't talk as much about, but it's important to note that account abstraction is kind of the ultimate theoretical goal for accounts in Ethereum. And moving beyond EOAs and allowing everything to just be a smart contract is a very elegant way of thinking about it. And I think there's a large design space and how to improve the user experience if we do think about, okay, we have these concepts called of EOAs. What if we replace them with some smart contract? And this is something that's not been thoroughly investigated yet, and I think should continue to be investigated. I just wanted to put that out as a point. And so if we look at what the pros of account abstraction are, we could say that it's a very elegant solution. Like I said, you replace the need for EOAs, and now you only have one account type in Ethereum. And that's very nice to think about in theoretical terms. It's also gas efficient to use compared to a lot of different solutions. Like there is an EIP, I think it's 4337. This is account abstraction, but without a protocol change. It's just an ERC, and it has a lot of indirection of calls, calling into other contracts, calling into other contracts, and passing around the data through all those calls and just instantiating those calls is not as gas efficient as this account abstraction, where you just go directly to the wallet and you let it start executing. So that's a nice thing about account abstraction. And then, of course, like it solves the UX issues that we had outlined in the beginning. It's not without its cons. That it's expensive to deploy, and that was one of the points about smart contract wallets that I was mentioning earlier, is that even just deploying a proxy contract, which is just kind of like the most minimal thing you can come up with, it's just maybe 200 bytes of code. This is still expensive for users to deploy. And so account abstraction does not fix that. You still have to deploy a contract to the chain and pay for that to happen. Maybe there's this design space like I was talking about where we replace EOAs with a contract, and that could alleviate some of those concerns. But I think generally with account abstraction, you have to pay to migrate your data over. It's also just generally a complicated change, and there is this potential for denial of service if clients are configured incorrectly. And I say it's complicated because this has been around for a really long time. Vitalik had written about this in 2015 about having some sort of account abstraction or abstracting different parts of the protocol away. And we've been working through different ways of approaching this and solving this for about 6 years. So I don't think this is something that's going to be coming immediately after the merge. I think that if we do see account abstraction come to the protocol, this is still several years away from happening. So that leads us to the letting EOAs execute code. We had our solution of letting the contracts originate transactions, and now we're going to look at how to let EOAs just go ahead and execute code. They can already originate transactions, but what if they were able to also execute code in the context of their account? And so one of the first solutions in this space was EAP 2803, rich transactions. Nick Johnson originally wrote this maybe sometime 2019, 2020. And roughly what it allowed is it allowed you to submit a transaction and have an additional field in the transaction that would be a script. And you would just submit EVM bytecode with that script, and it would execute like in the context of that account. And so you could easily have batch transactions by just submitting a script that says, okay, first call my DAI contract to approve, and then call the Uniswap contract to create the swap or whatever. And then we had this other flavor that the Quill team has worked on a lot over the last year called EAP 3074, and it introduces these two opcodes, auth and auth call. So we spent a lot of time thinking about the best ways of letting EOAs execute code. And, obviously one of the things that we looked at was this rich transactions. How does rich transactions work? What does it take to implement this in the protocol? And what we found is that it's a much more brittle solution than we were able to come up with 3074. It wasn't as flexible to allow the things that we wanted to allow. And it was just generally a larger change than we think that client developers would see as acceptable. So we focused on 3074, and if you're not familiar with 3074, then the short summary is that it allows EOAs to operate like smart contract wallets. And now just to talk about what does 3074 actually introduce, it gives us these two new opcodes, auth and auth call. So the magic of 3074 really comes from this auth. Basically, what auth does is it allows you to submit a signature and a hash, which we call a commit, which is just hashing the actions that you wish to perform, and it recovers the address that signed the full auth message, which includes the commit, and then it sets a new context variable to that address that was recovered. And so we talked about context variables earlier when I was talking about this message.sender concept. So now we have a new one that would basically say this address is authorized in this frame of execution to be called as, and that's what auth call then does. So auth call replaces the message.sender in the call with the address that's in that context, that authorized context variable. So it's almost exactly like the way the call opcode works today, except instead of message.sender being the contract that is using the op, it's actually that address that's been recovered and set as the authorized context variable. So the high-level flow of how a 3074 interaction would look is you have a user that signs a message, and then they send that message on chain and have a contract verifying the message, and then the message is parsed into actions and executed. And concretely, what that would look like is you might have something where you say approve DAI and trade for ETH. That would be a message. Or you might say if ETH drops below 1,000, then just buy 1 ETH on Uniswap. That could be another message. And those messages would be signed and submitted to the contract. And then the contract would take the signature and the hash of the message, and it would verify who signed that message. And then once it's verified, it would actually go and parse the action that you submitted and execute them using the auth call opcode. And so we say that these actions, these auth and auth call actions, occur within a special contract that we call the Invoker Contract. And this is a special term for 3074 contracts that are invoking the opcodes. And the reason that it's special is that it enforces the rules that you've encoded in the commit. And if we try to unpack that and understand what types of things it might be enforcing, we should look at what the message format that the users are signing actually is. And so that's it right here. It's this type byte invoker address commit. And the type byte is a discriminator that makes it so that you don't have any sort of conflict with maybe an EIP 155 signed message or a signed 2718 transaction that creates its own field of available things to sign. And then you also have a discriminator, this invoker address, which says this auth message is only valid in the context of this invoker. And that avoids the situation where you just submit a transaction on chain and then somebody else takes it and sends it to a malicious invoker. So those are the two things that are like relatively fixed. And then you have your commit that's very arbitrary. It can be any kind of data that you want. It's just a 32 byte value. And so for a really simple 3074 auth message, you might have a commit that is the nonce and the to and the gas and the call data, just basic information on how to execute a transaction. But you could also have something more complicated, like a multi-call, having all of these different calls rolled up into a single commit hash. If we zoom out and look, what is the full end-to-end execution of a 3074 message, then it would look something like this. I didn't talk a lot about how a sponsor might come into play here, but you can see like if I don't have ETH and I want to pay for my transaction with DAI, I could sign an auth message and send it to the sponsor. They could decide to accept or reject it. And then after that, the transaction that has the auth message in it would be sent to the invoker. The invoker would do that flow like we talked about, where they check the auth of the signature and the commit, set that authorized address. Then they parse and execute the commands down here. And then if you've sponsored your transaction, you might transfer a payment to your sponsor via some token contract, and then it ends up returning. So that would basically be the end-to-end flow with the 3074 interaction. So the thing to take away from 3074 is that it solves all of these UX problems that we talked about for all users, and it does it at no cost to them. And I think that the last part, at no cost to them, is very important because, like we said, having to deploy a proxy contract, it's never going to be free to deploy a contract. And I think that's always going to create this chasm that's difficult for mainstream users to cross. So just to close out the 3074 portion, we'll look at the pros. It's a pretty simple EVM change. My coworker Ansgar was able to implement the entire change in an hour workshop that we did in Paris a few months ago. And he wanted me to emphasize that it was the time that's impressive, not the person. So it was impressive that he was able to do it in 1 hour, not that he was able to do it. All users immediately benefit from 3074. It's not like smart contract wallets where you have to deploy a contract wallet and migrate your assets. You could just start using it immediately just as is. And I think that the really cool thing is that it creates a Schelling point for contract wallet functionality. Rather than having to have all of the smart contract wallet teams decide upon what the standards for smart contract wallets are going to be, it just takes one really great invoker to exist for for wallet providers to start using that as the way that they send batch transactions. So as soon as MetaMask and Rainbow jump onto that, this is a strong Schelling point for things like Web3.js and Ethers to start saying, okay, we should support that kind of functionality natively and allow dApp developers to use it. And of course, it solves the UX issues that we talked about. It's also not without its cons. Generally, invokers are difficult to write for a lot of reasons. I recommend listening to our talk from ECC about 3074. We do go into more detail about that. Ether may not be transferable. There's like really good reasons why this may not be the case. We're still working on maybe resolving this, but I recommend checking out the Ethereum Magicians thread on 3074 to see the discussion about why this is the case. It breaks some flash loan protections. These are really weak forms of protection. I don't recommend anybody relying on this to protect your smart contracts from flash loans. But if you do message.sender equal tx.origin, it would potentially break that if you're using that to make sure that a flash loan is not coming. Okay, these were basically the two different ways of improving the accounts in Ethereum. And I think it's really important to point out that these are not at odds with each other, even though it may seem that they're going in separate directions. I think that they can very much live in harmony together. And I actually wrote this post recently about validation-focused smart contract wallets. And I think it's important if we start thinking about wallets and synthesizing, like, what is the most core piece of what a wallet is? And I think that validation is that core piece because every wallet validates differently, whether it's, the owner of this account is this address. And so that should be what is recovered for a signature, or maybe the owner of this account is a multi-signature of many different accounts. And so that's the key piece. The machinery that executes transactions, like whether it's batching or whether it's a deadline that transaction is only valid up until this point, these are things that all wallets can share. The same code path should be executed. And so if we focus on just validation, I think that we can allow both account abstraction and things like 3074 to exist together in harmony. And so if we just look at what would this look like if we did have 3074 and we wanted to do account abstraction, we have the same flow that we just did with 3074, but we get rid of this middle part where we are just taking auth and recovering the address from the signature. And we add this from address. And so now auth is like, I don't understand this signature or commit. I'll just call this address that you've given to me, this from address. I'll call into it and I'll let it determine if that signature and commit is valid. And if it's valid, then I'll just allow this contract to make auth calls as that user. And so in this way, like, we're calling into the contract to do the validation rather than imposing top down what the validation logic for all accounts should be. So that was probably a lot of information. If you want to ask me questions directly on Twitter, feel free to @LikeClients, but I can also take some questions if we have time here.
Hey man, thank you so much for that talk. Exciting work coming from you and your team on 3074 and all that jazz. So we do have some questions from the audience, and if you could answer some of them, that'd be great. First question from Anonymous with one upvote. How do you see smart contract wallets evolving in a multi-chain world?
Yeah, this is one of the things that I really like about 3074. Of course, like when you say multi-chain world, I am going to like specifically focus on EVM compatible chains, because I think that there's like this huge design space of what you could possibly do if you had EVM and non-EVM chains being compatible. So if you imagine like what are smart contract wallets going to look like with this multi-EVM compatible chain world, then I really like the 3074 approach, where you just have to any party could deploy one invoker to those different chains, and now all of the users can use the same functionality that they're using on the other chains. And this to me solves a really important problem that I don't like about the way we're going right now with smart contract wallets. I don't want to have to deploy my smart contract wallet to Optimism and then Arbitrum, and then I withdraw to mainnet, and all of a sudden, all of the UX that I'm used to on those layer 2s is completely gone. And so that's why I think we should really think hard about how to allow users to seamlessly move across. And I think that 3074 is a potential path for doing that.
Next question from Anonymous with 2 upvotes. Are there any notable security risks with having externally owned accounts being able to operate as smart contracts?
There's a lot of discussion about concerns with 3074 and the kinds of security implications. I'm a pretty strong opponent against these kinds of arguments. And I'll say what the argument is, and people can make their own decision. But basically the argument is that if you were to have some sort of malicious wallet, like if MetaMask decided they were going to go rogue, they could force you to accidentally sign one message and remove all of your assets from your account. This sounds really concerning, but I think that this is like really missing the full point of blockchains and missing the point of like the trust assumptions you make. MetaMask already has full access to your key. The fact that we don't have batch transactions yet is just where we are at in the current timeline of Ethereum. I don't see a world where we go to where we don't have batch transactions. So it's like, okay, we're going to have batch transactions. MetaMask has your key. At some point, MetaMask could send an update that takes all of your assets in one transaction. So 3074 isn't special in that sense. And then we just like also have these people who let's see. There's one other security implication people had. It's escaping me right now. If I remember it, then I'll bring it back up on the question.
Thanks a lot there. Next question is, what is attraction of, and I'm going to assume this is abstracted accounts. So what is the attraction of abstracted accounts as an ERC20 if it's gas inefficient? Like, what are the pros of that versus having it implemented at the protocol level?
So I mean, the pros of having it implemented at the protocol level is it's just a much simpler implementation versus what has been proposed with 4337. The implementation of 4337 is, I don't want to say brittle, but it's just a lot more complex with the flows of the way the calls happen and having to shuttle information between call frame and call frame. Having it at the protocol level just makes it a much more native experience. You're able to deploy a smart contract wallet and then just immediately take advantage of it rather than having to rely on these third-party providers. And like an important thing to note about 4337 is it like generally relies that there is this relayer network that's willing to relay your transactions. And so anytime you have this assumption that there is a relayer network and the relayer network is smaller than the number of nodes on the Ethereum network, then you kind of have a different security assumption that a liveness assumption that you're going to be able to get your transaction onto mainnet.
And last question, when EIP 3074 Moon brackets mainnet?
I think this is where you're supposed to say soon TM.
Yeah, we've been saying a lot of.
Realistically, I think the next feature fork that we're going to have is probably going to be called Shanghai, and it's going to happen maybe sometime the end of next year after the merge. So that would be the target date for having something like 3074 go in, but those conversations will happen sometime March to May next year.
Lots of exciting things to look forward to for Ethereum, and especially when 3074 gets implemented, it will be sick for the UX on Ethereum for sure. Matt, are we still on for skiing? are we still on for skiing and snowboarding? Like in sometime?
100%.
Dope.
I just
I'm looking
learned how to not die in avalanches, so I'm pretty ready.
Nice. We'll do some backcountry skiing then.
Yeah, let's do it.
But yeah, dude, thank you so much for your time. I really, really appreciate it. We all do, I'm sure. And your talks are always so informational and educational. And yeah, like as you can see in the chat box, yeah, people are excited. So thank you so much. Feel free to stick around. We got Robert Habermeyer and then Joe Lubin coming up next. So
awesome.
Stick around.
Thanks a lot for having me. This is an awesome event so far. Really cool platform.
Thank you so much. Yeah, and yeah, happy to have you on again soon. Okay, bye. Okay, cool. Up next, we have a very, very big speaker coming up next. Robert Habermeyer. He is co-founder of Polkadot, CTO at Parity Technologies, Parachain's core team lead. He has a background in Rust, distributed systems, and computer security. He's also, according to his LinkedIn, not an automaton. Rob also joined us last year for CSCON 0, so it is an honor to have him come on again to give us a presentation, especially during this extremely exciting time for Polkadot. And if this becomes a yearly tradition, Rob, I certainly would not be complaining, and neither would the rest of ChainSafe and the world, actually. So it is my honor to introduce Robert up onto the stage, who will be talking about Polkadot's launch from a technical perspective. So Robert, if you would like to come on stage. What's up?
Hey Tim, wow, what an introduction. I feel like I should, work on my dance moves or something.
Yeah, let's do it. All right, I'll let you take the stage here, and yeah.
Awesome. Yeah, great to be here. Yeah, I've been here last year as well, and I really enjoyed it. Back again, after another year of development. Let me pull up the presentation, and I'm assuming that's all good.
Yes.
So yeah, I wanted to talk about the Parachain's launch today, which is it's kind of a big moment for Polkadot in general. I mean, we've been working very, very hard on building this technology, and when it comes to Polkadot, there's a lot of things to talk about. I mean, you can look at it from a lot of different perspectives of from the tech, and this is more of a technical audience, so I was going to dive into that a bit more. There's the community, there's the developer tooling, there's the ecosystem. I'm not going to touch on a lot of those things. I'd say that they're all happening. There's cool stuff happening in all of those domains. But I want to give a little bit of a recap, because I don't know how familiar all of you are with Polkadot, or sort of where we've been in our launch. I mean, there's a lot of noise on the internet, and sometimes if you're not following these projects day to day, you might not have a clear picture of exactly where we stand. So my goal today is really just give you a sense of where we're at with this technology, and where it's going to go over the next couple of years, where our priorities are as a development team, building this base layer. So without further ado, I'll jump into the timeline a bit. What's happened over the past I guess couple of years now at this point. So obviously we had a lot of development work in the run up to the beginning of this timeline. That's the initial commits that were made to our Polkadot repos were at the end of 2017. So we had a 2-year development cycle before even getting to launching value-bearing networks, to the point where we felt confident that this code could be used for that. That involved building out sort of prototypes, doing all of the research, building the substrate blockchain framework, testing it, implementing those bits of research and so on. But by the end of 2019, we had gotten into a point where we were able to launch the Kusama mainnet. What Kusama is, it's still around today. It's still being used quite heavily, actually, I might add. It's a beta or canary network for Polkadot. So it was one of the first live proof of stake networks in existence. especially from this sort of newer category, like second-gen proof of stake, which involves taking classical consensus protocols and slashing and using that to provide consensus as well as economic security. So it's really one of the first, if not the first, to launch with that type of technology. It's the same stuff that's being used on Polkadot today. It's the same consensus protocol, the same slashing mechanism. There have been a few tweaks and optimizations and stuff, but it's really the same code. That's the babe and grandpa consensus stuff. And that, that had a few hiccups, but we had gotten them all ironed out by May 2020. And that was a permission launch by the Web3 Foundation, same technology. And then over that summer, migrating to fully permissionless transferable proof of stake network. And at this point, we had roughly completed the research that was necessary to build the parachains technology, which is Polkadot's sharding technology. This summer, parachains went live on Kusama. So there was first a shell parachain, which is basically it's just a dummy. It's like an identity smart contract or something like that. Roughly the equivalent of that. It would be, it's a chain that doesn't do anything. It grows, it advances, but there's no transactions, there's no value. That's what we used to make sure that the agreement on agreement stuff was actually working in the wild. That was working on the Kusama chain, which is a network with 900 globally distributed validators at a time. I think at the moment it's 1,000. And then there were 5 auctions for other parachains, and at the moment I think there are 15 or 16 parachains live on Kusama. Like they're still going up. And now parachains are imminently going live on Polkadot. In fact, there's already a shell parachain on Polkadot, which shows that the base consensus primitives are working on there. And shortly, the first 5 auctions will begin for parachain slots. Well, actually, the first 5 auctions will conclude, and those parachains that win them will go live. It's hard to pin down the exact date that that's going to happen. It's probably going to be the 17th or the 18th, but it's based on block number. So the governance of Polkadot kind of determined a block number at which those parachains are going to go live, and it's either going to be the 17th or the 18th, most likely, unless blocks really slow down. But one of the things I really want to get across in this talk is the fact that this is really just the beginning. I mean, you could think of it as akin to when Ethereum Frontier first launched, right, in late 2015. The protocol has changed a lot since then. And the code has become much more mature. There have been a lot of optimizations. The client landscape has varied wildly. And I expect kind of the same thing to happen in the Polkadot ecosystem, which is what we're talking about launching here is really just an MVP. And obviously, as these projects grow, you get a lot more surface area to think about really interesting things. And a lot of the speakers at this conference have been talking about Ethereum protocol, or things that are happening in the Ethereum space, and it's amazing to see like how this surface area really blows up and expands. And this is really an end. This is really a beginning and not an end. I want to take a quick detour through the scaling technology landscape just to give a bit of background on what are the options and what are people talking about lately. So I think you have three main buckets, and these first 2 are rollups, optimistic rollups and ZK rollups, and this is what you would typically refer to as L2 scaling, especially within Ethereum space. These are the primary forms of L2 scaling that are being discussed, and then you have sharding as well, and sharding being consensus level. So I want to go through some of the differences, the advantages, and the drawbacks of each of these, and then sort of connect that to what we're doing with Polkadot with parachain. So with an optimistic rollup, what you're talking about is an L2 blockchain. So it's a layer 2 blockchain. It's a second blockchain where the headers, or something like a block header, that contains a commitment to the full state of all accounts and contracts and things, get posted to the L1 chain. And what you do is you basically allow certain groups or individuals or actors to post those headers, and then you wait. You have a waiting period where anybody's allowed to challenge them and like prove that they're bad. And if they do turn out to be bad, then there's some slashing mechanism on the L1 chain, or there are a few different ways to do it. But that's the rough concept. And I think the advantages to this is you have very, very fast execution. As long as everybody's behaving well, that's why they're called optimistic rollups, because as long as everybody's behaving well, it proceeds very quickly. But you do have this slow finality because you wait for these long fraud periods, and if there are actors who aren't behaving well, it can really throw a wrench into the gears of the system. So those are the benefits and the drawbacks. I think people can already build optimistic rollups today. They're not particularly difficult. I mean, you won't do one in a weekend, but you'll certainly be able to do one with a few developers over a few months or a year. Very interesting is the second category, which is the zero knowledge rollups. I mean, this is really an incredible field of math that's been developed for decades of zero knowledge proofs. And what this is mostly about is sort of proof combination and aggregation. Like everybody kind of gets to prove that their transaction was valid, and then you have these aggregators that are rolling up hundreds or thousands of these proofs into a single proof. And then the layer 1 blockchain can validate all of those transactions at once. Now, that's really cool. It's an incredible property of zero knowledge proofs that you can verify stuff faster than it takes to execute. I think that's a sort of a probabilistic escape hatch, but it's overwhelmingly unlikely that you would verify something bad to be true. But it's very expensive to prove and aggregate these things. It might be very high CPU. In the end, it might encourage centralization, and the state-of-the-art technology, on paper and in implementation, is quite far away from fully general execution. We are now, really interestingly, seeing the first forays into that type of thing, but it has not really, been developed to the point of actual usability. And I think the general consensus is that it's at least a few years away. So then there's also sharding, which I'm sure you've heard a lot about, which is about consensus level changes to split work across a validator set. The core takeaway being that not everybody executes everything, and then it's very hard to guarantee security. It scales, but only quadratically, at least if you have message passing. It's very technically difficult to implement because you can have cascading failures if one shard has a bad transaction and that pollutes another shard, which pollutes another shard, and then all of a sudden your whole system is kaput. But you can have very fast finality and fast agreement and incredibly high throughput in a sharded system. A lot of it comes down to just clever engineering. Once you get the protocol nailed down, just to improve the networking code and reduce those bottlenecks. Even though it scales quadratically, I expect that sharded systems can be pushed very high in throughput. So we use a form of what we call heterogeneous shard in our parachains technology. So every parachain defines its own validity criteria. It defines what a block is composed of, what data it needs to check that a block is good, and what executes in order to check that a block is good. Maybe one day this could all just be zero knowledge proof stuff, right? Where the proof data is just some kind of cryptographic witness, and the validity function is just some circuit checking logic. But for now, this is WebAssembly, right? This is subsets of Merkle trees or other cryptographic accumulators, and as the input data and the witness function is or the validity function is just a WebAssembly blob. So it's heterogeneous sharding in that every blockchain kind of does its own thing. Now, I could have an entire talk about like all of the different things that people are doing with this primitive of writing their own blockchains. But for now, I want to keep this at a higher level of abstraction. We just kind of know that all parachains are doing a separate thing, but that's not really the main focus point of how do we scale the protocol and how do we make the protocol faster. And I have a couple diagrams here as well, just to sort of nail that down. The way that Polkadot works effectively is that it's providing, we have one chain we call the relay chain. This is sort of akin to the beacon chain in Ethereum, in Ethereum 2.0, which is sort of providing scheduling and consensus and security for all of the registered parachains so they advance in lockstep. And the way I like to frame this is that, if you want to 51% attack one chain, you have to 51% attack all the chains at the same time, because their fork choice rules move in sync with each other. And that's sort of the mechanism that we kind of get an advantage that optimistic rollups don't have. In an optimistic rollup, you don't have influence on the layer one's fork choice rule or finality rules. In sharded systems, like Polkadot parachains, a bad parachain can actually be avoided on the layer one fork choice rule. So that's, I think, a key differentiation. You can also have some parachains that are bridges. They could bridge to Bitcoin, they could bridge to Ethereum, or you could, go one level further where there's an EVM parachain that implements a bridge, and that bridge connects to all the other EVM parachains or things like that. So it's heterogeneous sharding. This diagram kind of shows that a bit. We have a few different key actors. We have collators who actually author. They know how to create valid blocks. Validators get moved around all the time. The only thing they need to know how to do is validate blocks and move data over the internet. I want to move on and talk a bit about basically optimizations, because everything that I've talked about so far, this is implemented already. This is what's launching on the 17th or the 18th. The next step for us is really on the protocol side. It's all about engineering and optimizations. The framework and scaffold that we have gives us a lot of room to maneuver. We've done essentially the most basic version of parachains. It works, but the upgrades that are going to be coming over the next year, the next 2 years, are just going to make it a lot faster. And that's upgrades within that parachains V1 model, and also within that parachains V2 model, which is the further out pie in the sky style research of what happens if we're running multiple relay chains and moving validators between those relay chains. That's the really far out stuff. That's the stuff that's really going to ratchet up the scaling even further. But even within this parachains V1 model, if we have one relay chain with a bunch of parachains attached, and those parachains are the leaves of the tree. They don't have their own parachains or anything like that. Even within that model, there's a lot of room for optimization. And this is the near term stuff. So you guys are generally, I guess, a developer audience, and you can appreciate the near term optimization and engineering effort that's going to go into this. So the main things that are coming up from the system, and the rest of this talk actually I'm going to dedicate to I think what is the biggest one of these is asynchronous backing, which is it's a protocol level change that allows parachain blocks to be pipelined and prepared well in advance of inclusion on chain. What this essentially means is that, well, right now, if you look at like Polkadot or Kusama, parachain blocks are coming in once every 12 seconds. They can come in once every 6 seconds, and beyond that, they can have we can spend much more time validating parachain blocks than we do currently. At the moment, we have a soft limit of half a second of execution time given to each parachain block by validators. And the goal is to get this up to something like 3 seconds per 6 seconds instead of 0.5 seconds per 12 seconds. Furthermore, the goal is to get more witness data. More data is more throughput. We're also interested in parathreads, so dynamically scheduling parachains. This is is an optimization in the sense of it allows the system to have more parachains by attaching them as parathreads. These would be sort of a middle ground between the deploy a smart contract and build your own 24/7 blockchain. Pay as you go parachains. This is I think a really important factor. And then a bunch of networking optimizations. Like our networking code is, it's functional, it's fine, but there's a lot of really clever stuff that you can do. Taking more inspiration from things like BitTorrent, playing around with the topology, scale-free networks. There's a bunch of ideas that we have floating around on the research side that will enable us to transmit data over the network more quickly, which is probably, if asynchronous backing works, networking will become the primary bottleneck. So with that in mind, I want to dive into this asynchronous backing thing because it's the main roadmap item coming up. So the goal is to release a version of the node that does this type of thing sometime in the next few months. So I want to dive into the two parts of this term. So backing is the process by which validators accept and attest to the validity of new parachain blocks. Essentially the mechanism by which we get skin in the game. It's not a security mechanism, except that it gets skin in the game. There are other security mechanisms, but one of the nice things about our design is that the inclusion process of making sure that stuff gets referenced on chain is different than the processes that actually provide security and finality, which means that we're in this really nice space from an engineering perspective where we can optimize without worrying about breaking safety. We might break liveness, if there's a bug that causes a stall, but at least you won't break safety. So that's kind of a nice place to be optimizing from a practical standpoint. Backing is about notifying the relay chain that of the header of a new parachain block, and that enough validators from its group or committee have actually signed off on the block. By asynchronous in this sense, I mean that we disconnect the progress of the backing system, of the backing process, that's supposed to say, sorry, from the growth of the relay chain. So right now, they move more heavily coordinated. They're more synchronized with each other. You can't start building the next parachain block until the next relay chain block has appeared. And this is mostly for architectural reasons about you have to know the state of the message queues before you come in and build a new block, because you have to know what the latest states of the message queues are and things like that, or what the most recent block header that's referenced on the relay chain is. So that's why those things are more synchronized now. And we're looking at a set of optimizations that will allow them to become asynchronous. So the next few slides, I want to walk through basically what this really gets us. So on Polkadot, blocks are 6 seconds. So we have relay chain block 1 to relay chain block 2. The arrow on the relay chain indicates a parent relationship, right? So R1 is the parent of R2. On the lower level of the diagram, it's about the flow. Sort of the actions that are being taken. So, validators see R1 being built and they'll start doing this backing process. It basically means they'll get a parachain block from a collator, they'll check it, they'll start signing off on it. Once they have a quorum, then they can submit that quorum to the relay chain, right? And this is fine if you can do it in 6 seconds, right? If you can do it in 6 seconds, if you can get it from a collator, get enough people in the committee to sign off on it, and then get it to the block author who actually includes that in the R2 that they author, that's fine. But what happens fairly commonly is that you're just a little bit too late. It doesn't come in 6 seconds, it'll come in 8 seconds, or we'll get the consensus done in 6.5 seconds. It doesn't matter. As long as you're too slow, even by a little bit, that's not getting included. And that's kind of a problem, because when things are working smoothly, you have this repeated cadence of backing, inclusion, backing, inclusion. You get this this rhythmic thing. But if things are off even just a little bit, consistently, the parachain might stall until the network can make a block fast enough to break that stall. even though things are just being missed by a little bit, we constantly have to go and start from scratch. And if you go on, the explorers for Kusama, you see this happens sometimes. And this is what it can be pretty much entirely attributed to. But the interesting thing is that this is totally just it's just a factor of us not using the scaffolding of the parachains protocol to our full advantage in the in our implementation, right? So what we're launching right now is something like the minimal version, but essentially over the next 2 months we're going to get it to look something more like this, which is if by some accident you accidentally take 7 seconds instead of 6 seconds, that's fine. You can just reuse that result in the next relay chain block, and you can also immediately start building the next parachain block on top of that. And the goal here is to totally decouple the extension of the parachain from the extension of the relay chain, so that whenever you author a relay chain block, there's always at least one new parachain block ready to be included on the relay chain. So that's the goal of this optimization. And the reason I want to talk about it is because that's sort of the thing that me and my team are working on now as our main protocol optimization. So always helps to talk about what's currently going on. And yeah, so this is the thing. There is a there's a big GitHub issue right up on that. That's going to get transformed into something of a loose implementable spec. We have a document which is called the Implementer's Guide, which has been the primary implementation document of the Polkadot node. And the idea here is to specify the behaviors and interfaces of all the components that go into a node, both on what we call the runtime or blockchain logic half of it, or also in the node side, like networking and execution layers. So that's going to be transformed into an amendment to the implementer's guide, and then from that we would actually know exactly which changes we need to make to the code base. So keep an eye out for those changes. We should have this on the test nets sometime early next year. And I wanted to go into this in a bit more detail. So just reiterating what this diagram means is that even though we missed the window of opportunity, we can still include the parachain block in the next relay chain block instead of starting over. And we've already started backing the next parachain block even before then. So that those labels might make it a little bit easier to understand. Summarizing exactly what the goals are here is more time spent executing transactions, because it doesn't matter if we miss our window slightly, and we'll also be building these things optimistically off chain. And anyway, so there's always going to be something ready to include. Less risk of wasted effort. The downside of wasted effort, or the downside of missing the window is much lower. And larger proofs of validity. All of these things together mean smoother block times. They mean more execution, and they mean more data going into that execution, which translates to more throughput, all in all. More predictability, more throughput, lower latency, all of that stuff. And we have less reliance on speedy internet, because right now, with that short window, it's encouraging validators to move closer to each other geographically so that they can try to make that very narrow window. Latency is a non-negligible factor. After these changes, latency won't be nearly as important, because it'll be, we'll be dealing with longer block authoring windows, where execution and bandwidth are going to be much more important than latency. More time to author and execute blocks combined with that means more decentralization. So we will have, validators that are more distributed globally, that feel comfortable being more distributed, so that we won't have this implicit reward points system pushing them closer together. It won't be as much of a factor, and we'll be able to accept, say, less less stringent hardware requirements on validators. So I'm going to leave you with a couple of takeaways. So one, Polkadot parachains are just launching, and this is only the beginning of our engineering efforts. In the meantime, we're building up our engineering teams a lot to focus on these things as well as others. So we are hiring for that, and we have a lot of sort of low-hanging fruit for optimization in our protocol and our code. Anybody who's worked in a blockchain node knows how complex these code bases can get, and how often easy and gratifying it can be to just trawl through them and find issues or optimize some subsystem. So thanks for attending, everybody. I don't know what time it is, but if I have time for questions, I'd love to answer some of them. So thank you for that.
Awesome. That was an amazing talk, Rob. Thank you so much. We do have a bunch of questions, so would be happy to hear your insights on some of them. First one from Jimmy with 5 upvotes. Way to go, Jimmy. I know Polkadot has a shared security model, but how important is individual parachain security? Does the Polkadot network prevent or mitigate against a malicious or corrupt collator set?
Yeah, that's a really good question. So I think the easiest way to break this down is that parachain collators are only responsible for liveness. So they're basically only responsible for is somebody creating new parachain blocks. If you don't have any collators, nobody's going to be making blocks. If there's one collator, then only that one collator is going to be making blocks, and they'll kind of have control over what gets included in those blocks. So it's good to maintain a healthy collator set. The relay chain validators are completely responsible for the safety of the parachains. So that is, making sure that, and the way that we frame this is, no parachain block should ever appear in the finalized part of the relay chain unless that parachain block has passed the validity function. So we heavily integrate parachain validity with relay chain finality. So it's an integrated part of our fork choice rule. We have 2 security protocols, which are called approvals and disputes. What approvals is about is using a technology called VRFs, which is sort of like verifiable dice rolling. Like I can roll, and I'm talking about like a gajillion sided die and prove to you that this is what I rolled, to have validators self-select to check the parachain blocks randomly. And we make a security argument with Gambler's Ruin, which is that we have enough people checking that at least one of them needs to be honest. And if any of them are honest, then it will be escalated. And if there's an escalation, everybody checks it, and whoever's wrong will get slashed. There are more complications and sort of edge cases to the approvals protocol, which is like what happens if people say they're going to start checking stuff and then they disappear. That means there's probably an attack, and then we have like a replacement protocol as part of that. We do have write-ups on all of this stuff. But to answer your question, parachain validity and safety is incredibly important.
Okay, we'll get 2 more questions in there just because we're running a little bit behind on time. So I'll just go for the next 2 with the highest upvotes. So one from Anonymous with 4 upvotes. Will we see a dedicated parachain for bridging or more spread around bridges on different parachains in the future?
I expect that we're going to see like a lot of different approaches to bridges. So we'll see, people who are doing more custodial style bridges that are just launching smart contracts on some smart contract enabled chain on Polkadot, like Moonriver or Moonbeam or Plasm or Astar or whatever, is doing smart contracts on Polkadot. They'll probably launch things like that. We would like to do a parachain that is a substrate to substrate bridge hub chain. So, bridging and verification of bridging might not be that expensive. So you might be able to combine lots of these, especially if they're all using the same consensus protocol, onto one hub chain where the messages pass through.
For that. And then one more from Light Client. Thanks for sticking around, Light Client. Do parachain block producers rotate between parachains? If not, how do you feel about their ability to be corrupted, whether censorship or data withholding?
Yeah, they don't rotate between parachains. Collator selection, so parachain block producers, is it's a process that's entirely up to the parachain. So there's nothing on the Polkadot side that actually dictates that you even need to have a bounded collator set, although a lot of the optimizations that we'd like to do rely on having parachain block producers that are probably unique for that time slot. But a lot of parachains are using staking palettes, or even have tens or hundreds of collators that rotate or are chosen randomly with VRFs that are unpredictable. And we've designed our consensus protocol so they also work for parachains as well. So we think that that's about as good as any other proof of stake network.
For that. And also, we're going to mark down all these questions, and we can maybe shoot them over to you so you can answer on Twitter if you want. But otherwise, thank you so much for your time. Really, really appreciate you taking the time out to drop by and give us a talk and presentation. And hopefully we can do it again next year, or maybe even sooner.
Yeah, for sure. It was great to be here, and hit me up next year.
Yeah, awesome. And feel free to stick around. We got Joe Lubin and Aiden coming up. Thank you so much for your time. Really, really appreciate it.
For sure. All right. See you around. Bye-bye.
Okay, we're going to take a quick 5-second break. That's 5 seconds. Don't go anywhere. We just got to reset our YouTube live. So